Welcome back. This is question Q1b. In question Q1b, we are given x2n to be this expression here. Now, omega, the digital angular frequency, is 1.8 pi. Its unit again is radian per sample. It means that each sample, when n goes from 1 to 2, we are transversing by 1.8 pi for this sinusoid. Again, refer back to question Q1a. What we are trying to find is the internal expression here for theta. If n, capital N, can be associated with any multiple of 2 pi, then this signal will be periodic. Again, we substitute k equals to capital K equals to 1. When we substitute k equals to 1 and solve for n, we get a irrational number. What we need is for capital N to be integer. So we will manipulate this expression. We can ignore this 1.8 pi, and n is equals to 2 pi k divided by 1.8 pi. And now we are trying to find capital N and capital K to be integer. If we can find that, then we can find the number of samples to make this sequence periodic. In this, by inspection, we see that if we choose K to be 9, 2 times 9 is 18 divided by 1.8, the pi cancel, and therefore we get capital N equals to 10 samples. So every 10 samples, the sequence will repeat. Okay? Now what does K equals to 9 means? It means that actually the sequence is repeating 9 cycles already. And that means something strange is going on, and it's called aliasing. Basically, the sequence is moving very fast, but actually when we observe it, it's actually moving very slow. How slow? Well, first is at 1.8 pi omega, this is the same as observing minus 0.2 pi complex exponential rotating. So although the sequence is actually rotating at 1.8 pi, when we observe the sequence with n as integers, we are actually also observing it as a slowly moving sequence clockwise at minus 0.2 pi radian per sample. Okay, so let's see this animation now. I generated this MATLAB program to draw a complex exponential rotating clockwise at minus 0.2 pi radian per sample. 0.2 pi radian per sample is equivalent to 36 degrees. So in 10 samples, it will rotate 360 degrees. So this is a complex exponential rotating clockwise, as you see. The red representing the first cycle, the green representing the second cycle. You can also view this in a 2D, where the red moves from here to here in one sample, and this is 36 degrees. If you count the number of samples, it's 10 to make it move by one rotation 360 degrees. You can also view it in the real and imaginary part. The top is the real and the bottom is imaginary. To understand why I say that the complex exponential is rotating clockwise is due to the imaginary part. If you substitute R1ej omega n, and omega is minus 0.2 pi, and as n increases, you will see that the imaginary goes down first. And that is why in this 3D plot, it is rotating by going down first along the imaginary axis. With that, thank you.